Hello students, in this video we are going to discuss question number 17 to 21. It is the continuity to the previous video. Coming to question number 17, a platinum surface having the work function 5.63 electron volt is illuminated by monochromatic source of 1.6 into 10 power 15 Hz. What will be the minimum wavelength associated with the ejected electron? Here the given data work function is equal to 5.63 electron volt, that is equal to 5.63 into 1.6 into 10 power minus 19 joule in terms of SI system, and the given frequency is 1.6 into 10 power 15 Hz. We need to calculate the minimum wavelength of ejected electron. From the Einstein's photoelectric equation, we know kinetic energy is equal to h nu minus work function. That is also is equal to hc by lambda we will have. From this, lambda is equal to hc divided by h nu minus work function. That is, h value is 6.63 into 10 power minus 34 and c is 3 into 10 power 8 divided by 6.63 into 10 power minus 34, frequency value 1.6 into 10 power 15 minus of work function is 5.63 into 1.6 into 10 power minus 19. That is also is equal to 19.89 into 10 power minus 26 divided by 1.6 over minus 19 into 6.63 minus of 5.63. This is equal to 19.89 into 10 power minus 26 divided by 1.6 into 10 power 15 will get, after simplification, 12.4 into 10 power minus 7 meter. So this is the minimum wavelength of the ejected electron. Coming to 18th. In Young's double-slit experiment using monochromatic light of wavelength lambda, the intensities of the two sources is I. What is the intensity of light at point where the path difference between the wavefront is lambda by 4? So here, whenever the wavelength is lambda, the intensities of the two sources is I is given. So we have I is equal to, suppose say some I dash is equal to I1 plus I2 plus 2 square root of I1 I2 cos phi. This is the expression for the resultant intensity on the screen whenever the individual intensities are I1 and I2 and the phase difference between them is phi. Now according to the given data, I1 value is equal to I2 value is equal to I. So I dash is equal to I plus 2I cos phi. That is nothing but 2I into 1 plus cos phi. That is also nothing but 4I cos square phi by 2. But here, so the phase difference is equal to 2 pi by lambda into path difference. that is 2 pi by lambda. Path difference is given as lambda by 4. So this is equal to pi by 2. Therefore, 4I cos square, this one will becomes pi by 4. Pi by 4 cos of is nothing but 1 by root 2. This is 4I 1 by root 2 whole square. That is nothing but 2I. So this is the resultant intensity. Coming to question number 19. P and Q are two identical charged particles, each of mass 4 into 10 power minus 26 kilogram and charge 4.8 into 10 power minus 19 coulomb, each moving with the same speed of 2.4 into 10 power 5 meters per second as shown in figure. The two particles are equidistant 0.5 meter from the y-axis. At some instant, the magnetic field B is switched on so that the two particles undergo head-on collision. Then find the direction of the magnetic field. Here, the situation will be whenever they are at distance of 0.5 meter, they are head-on collision. Means they may travel like this, they may undergo head-on collision. That means, what is the direction of the magnetic field when it is possible? In this case, the magnetic force is acting like this for this one, and for this one the magnetic force is acting like this. It is acting as like centripetal force. So this is possible only if the magnetic field is into. Therefore, from Fleming's left hand rule, the direction of the magnetic field is into the plane. Then only that is possible. While coming to the magnitude of the magnetic field applied in this region, we have, so this one will continue in a circular path, both of them. Then radius r is equal to mv by qb. From this, b is equal to mv divided by qr. So that is equal to mass of each particle is 4 into 10 power minus 26 kilogram, and it is moving with velocity 2.4 into 10 power 5 divided by charge 4.8 into 10 power minus 19, and the radius is nothing but 0.5 meter. So if you simplify this one will be 4 into 10 power minus 2 Tesla, that is also nothing but 0.04 Tesla. This is the strength of magnetic field acting perpendicular to the plane, perpendicular to the XY plane. Binding energy per nucleon versus mass number curve of nuclei is shown in the figure. W, X, Y and Z are 4 nuclei indicated on the curve. Identify which of the following nuclei most likely to undergo nuclear fission and nuclear fusion. Justify your answer. While coming to the first one, nuclear fission. So which one will undergo nuclear fission is here W. The justification or reason we can write binding energy per nucleon is smaller for W with respect to X and Y. Second one, the nuclear fusion. They should be lighter. Here, the element Z undergoes nuclear fusion. Y means that is smaller, and at the same time, its binding energy per nucleon is smaller for Z with respect to X and Y. Here in the nuclear fission, W is already, that is bigger in size, that can't fuse, so that is splitting into. Here Z is already smaller, that's why there is undergoing fusion to get stability. To get stability means automatically binding energy per nucleon will be higher. Those elements which are having binding energy per nucleon is higher is more stable, which is having lower is lesser stable. Everything will try to get stability. And 21. What should be the radius r of nearest possible orbits of the satellite of mass m revolving around the planet of mass m as per Bohr's postulate in terms of small m, capital M, G, H, where G is gravitational constant and H is Planck's constant. Here we want the expression for the radius of the orbit of the satellite in terms of all these. Actually, from Bohr's postulate, from the second postulate or Bohr's quantization condition, mvr is equal to nh by 2 pi. So from this, velocity v is equal to nh divided by 2 pi mr. You can take it as equation number 1. And orbital velocity for the planet and satellite system, we will have orbital velocity v is equal to square root of gm by r. This one we will get by equating centripetal force is equal to gravitational force. Centripetal force is mv square by r, centripetal force acting on the satellite, and gravitational force is g capital M small m divided by r square. From this we can get orbital velocity is nothing but square root of gm by r. Take it as equation number 2. So from equation number 1 and 2, we will have nh divided by 2 pi mr is equal to gm by r under root. By squaring, n square h square divided by 4 pi square m square r square is equal to gm by r. Here one r will be get cancelled, and after simplification we will get r is equal to n square h square divided by 4 pi square m square gm. So this is the orbital radius in terms of n, h, 4 pi m, g and mass of the planet. Thank you. In the next video, we will discuss 3 more questions.